Our last speaker this afternoon is Dr. Christian Casey, who will be talking to us about reconstructing the evolution of Egyptian scripts through digital and biomechanical modeling. Christian Casey is a postdoctoral researcher in Egyptology at the Freie Universität Berlin. His work focuses on the evolution and phonology of the Egyptian language and the development of its writing systems. He specializes in applying digital and quantitative methods to the study of ancient scripts, integrating computational methods, modeling, handwriting analysis, and traditional philology. As principal investigator of the project Writing Through Time, Evolution, Iconicity, and Cultural Agency in Ancient Egyptian Scripts, he collaborates with an interdisciplinary team combining Egyptology, linguistics, and applied mathematics to reconstruct the physical and cognitive processes underlying Egyptian scribal practices. So, Dr. Casey.
Thank you, Dr. Benson, for the kind introduction, and a special thank you to everyone for putting this together. I'm really just blown away by the scale of this conference and the quality of the organization, so I'm very grateful to be here. So we're working on handwritten script evolution more generally. In theory, any script that people have ever written could fall within the scope of this project, but as an Egyptologist, I'm especially interested in the evolution of Egyptian handwritten scripts. And from the other direction, my colleagues are also especially interested in Egyptian because Egyptian provides this wonderful natural laboratory. We have dated manuscripts spanning 3,000 years of history. If you're familiar with the changes in hieratic and then the development of demotic, you can see that a lot has happened. So we have a wonderful source of evidence for studying handwritten script evolution from Egyptian, which is how I got interested in this topic in the first place. Just to quickly illustrate what I mean, this is the familiar G17 sign in hieratic, and I would say that a naive observer could be forgiven for not recognizing that these are two different forms of the same sign. Physically, they're quite distinct from one another. They look like totally different things. But if I add in some intermediate stages, quickly becomes clear how one sign form evolved into the other. And I'm using the term evolution quite deliberately here. This is an evolutionary process. It is analogous to biological evolution. The important point I want to make is that an evolutionary process is an optimization algorithm. It's an iterative process by which things change over time in order to fit some sort of fitness function. Really, all that's required is that you have reproduction with variation plus some sort of selection process, and then you have an evolutionary process. So I don't want to make too hasty a comparison between two different things, namely script evolution and biological evolution. Rather, these are two different instances of the same underlying phenomenon. And what we want to understand here are what are the mechanisms and the principles that influence and govern this phenomenon, especially in the case of Egyptian. So that leads to the first question: how can we actually study this? What do we literally do besides just talking about it? Well, one of the things that I'm very excited about is that we have funding to do experiments with historically accurate materials. So papyrus, reed brushes, carbon ink, and high-speed cameras recording the hand movements of people reproducing ancient Egyptian texts. We hope to use that to learn more about the production process of real ancient Egyptian texts. But we haven't done that yet. We're still just at the beginning of this. So what we have right now is an iPad app, which you can find on the App Store if you're interested in participating. It's called Pen Capture. And what you see on the screen right now is a screen recording of the Latin script. Specifically, this is the US cursive script. And we're recording data on how the pen moves over time, recording various physical forces involved. And with this, we hope to better understand the process of producing handwriting and how that process relates to the way sign forms change over time. You'll see a little bit more about this later, but there's some fairly obvious trends in the way sign forms change, and we want to better understand the underlying processes of those types of things. For now, working on hieratic, in fact, preparing digital experiments on hieratic. I'm using the AkuPal database from the Mainz researchers. And I have to say a special thank you to Dr. Svenja Gulden and Tobias Konrad for sharing their data with us. We have over 800 texts, over 37,000 sign instances from hieratic. And I'm also using data from the Thesaurus Linguae Egyptiae. I have to say a special thank you to Daniel Verning for sharing these data with us. 1,700 texts, over 1 million sign instances. And you'll see how I put this to use in just a second. So we're looking at the graphic representations of hieratic signs, specifically, SVG files, the shapes of the signs themselves. And we're also looking at sign frequency data from the script, combining those two things together. So this figure requires a bit of explanation. On the x-axis, you have information content, which is estimated from the TLA data. And on the y-axis, you have sign complexity, which is calculated from the actual physical forms of the signs. And because there are multiple instances of each sign in the data set, you have these sort of vertical stripes. It's a violin plot, so you have kind of a distribution of different sign complexities. And you can see that there's a correlation between information content and sign complexity, which is the key takeaway from this. And another way of thinking about it, a way of thinking about information content might be that this is the value that a sign has to a reader. This is how much information the sign carries. So it's more useful to me as a reader if it has more information. It's more valuable in some sense. And complexity represents the cost to a writer. So you could say, how long does it take to produce this sign, or how much physical effort does it take? How much burden does it place on the scribe's memory? Etc. It's a metric that serves as a proxy for all of these things. And with that strongly statistically significant but fairly weak correlation, so R equals 0.17, you can see that there's an alignment between cost and benefit. So signs that are less informative tend to be lower in complexity, and signs that are more informative tend to be higher in complexity. And this is all data from the Old Kingdom, but of course we have multiple periods represented in the data set. So if we go to the Middle Kingdom, you can see we have many more signs, and our correlation has jumped to 0.43. So we see a stronger alignment between information and complexity. In the New Kingdom, again, correlation jumps to 0.56. And then in the Greco-Roman period, 0.57. So you can really see a change over time. There's an optimization happening. Scribes are aligning the cost of producing a sign with the amount of information that that sign carries for a reader. So we're really thinking about this diachronically, and because we want to study evolution, this is one of the key mechanisms by which signs change. So returning to the familiar example of G17, you can kind of plainly see, without defining things too strictly, there's a change in complexity here. The sign on the left is plainly much more complex than the sign on the right, and we can, in theory, measure how that complexity changes looking at the full spectrum of data. So here you have another figure that also requires some explanation. Again, you have sign complexity on the y-axis. You have the dates of these signs on the x-axis. So earlier signs are on the left, later signs are on the right. And at the points in this scatter plot, instead of just having dots, you have the actual sign instances themselves plotted on the figure. And you can use this to get a sense of what I mean by sign complexity. Signs near the top of the plot are clearly more visually complex than signs at the bottom. And we can also just do linear regression on these data and get a slope value that represents what happened to the complexity of this sign over time. So in the example of G17, we have a slope value of negative 0.98, which means that this sign lost about 1 complexity point per year throughout Egyptian history. We can look at some more examples. So again, the familiar G1 sign, the Egyptian turkey vulture, you can see that it has a slope of negative 1.27. So again, it's becoming simpler over time on average. A1, also a familiar example, slope of negative 1.17. So we can see, again, a decrease in complexity, which is kind of what we expect. If you've studied hieratic, you have the sense that the signs become more abstract over time. But interestingly, we also have examples of signs that increase in complexity. So the D28 sign or the Ka sign in the evidence from AkuPal increases It has a slope of 0.89, so positive slope means that the complexity of the sign increased. And another really cool example, G35, or the ox sign, you can also see 1.49, the sign increased in complexity over time. And so now, because we have this single summary statistic, you might say, of the way signs changed over time, we can start looking at diachronic trends on the entire script level. So we can sort of look through time at the way the script behaved. And again, a rather dense plot, but you can see that we have information content on the x-axis, just as in the earlier examples, and we now have change in complexity on the y-axis. So anything, different button. So anything that falls below 0 became simpler over time. Anything above 0 became more complex over time. And you can see there's also a really nice correlation here. So less informative signs tend to become simpler, more informative signs tend to become more complex. And that really tells us something about the underlying mechanism here. They're not necessarily intentionally, but over time, cumulatively, scribes are better aligning the sign complexity with the information that the signs carry. And then just hopefully to make this a bit clearer, these are the 5 examples that we just saw in more detail. So you have G17, G1, A1, and then D28 and G35. You can see where they land on this, so that gives you a sense of how this figure shows the change in complexity on the script level. So I want to just quickly go to these concepts, which we're all familiar with if you've ever heard any discussions about Egyptian handwritten scripts. These are really distinct concepts. So abstraction, I would define it as meaning that signs become less iconic or less figurative. Cursivity means that signs are being adapted to fast, fluent writing. And then simplification means that the actual physical form of the sign loses features. It becomes simple in some way. But I think in practice, when we talk about these things with handwritten scripts, we often use them more or less interchangeably. We kind of have this notion that hieratic is a simplified version of hieroglyphs that then becomes simpler over time, and then things get messy, things get ligatured, and then we end up with demotic, which is even more abstract. And we have this notion of a diachronic trajectory that we all sort of internalize from our experience of looking at these scripts. And so then the question that I had for myself, because I didn't expect any of these results, I was in fact kind of blown away when I saw that correlation between change in complexity and information content. Why didn't I expect it? Why didn't I know that I was going to see this in the data? And I think the reason for this is that if you look at actual examples, so here's just a page from the Shipwrecked Sailor, and you have signs colored by their information content. And then just to remind you, looking back at this figure, our trend line crosses 0 at an information content of about 7 bits. So if we filter this to show all of the signs that are below 7 bits in information content, you can see that that's most of the signs on the page. If we look at the signs that are above 7 bits, it's a minority. So most of the signs that we see most often, the signs that we're most familiar with their diachronic trajectories, those are the signs that are likely to become simpler, whereas the rarer signs are the ones that are likely to become more complex, but they're also the ones that we see less often. So in our own experience, we're sort of biased to see the signs that become simpler more often, and that's probably what gives us this impression of increasing abstraction, but the data don't actually bear that out. So there's really 2 separate phenomena here that are interrelated. We have simplification, which is something that we're very interested in studying. I really want to understand the physical process by which signs become simpler. It's quite clear that it's not purely random. There are some trends here, like certain things tend to be linked, certain corners tend to be rounded. It depends on the actual physical production of these signs. But it's a more straightforward process than the process of complexification, where in theory, really anything can happen. If I have a handwritten sign and I want to make it more complex, really there's no limit on what I might do to that sign in order to make it more complex. And just to illustrate, the sign Z in the Latin alphabet is poorly optimized for the English language. This is a high information sign, but it's graphically a very simple sign. So in response, in US cursive, we added a tail to it, right? We made the sign more complex to better match its information content. And that makes sense because tails are kind of a feature of this script. It's a modular element that we can just borrow and add to this sign when we want to make it more complex. But what do we do for Egyptian? Well, Egyptian is marked by iconicity. The hieroglyphic scripts never totally discarded its iconicity throughout its history. And we can see that they can use iconicity as a way to make signs more complex in this more or less extemporaneous fashion. So the D28 sign in the Old Kingdom is very simple. It's just basically 3 lines. But then in the Middle and New Kingdom, they started adding hands to it. So when they wanted a way to make this sign more complex, they could use the fact that this represents a real-world thing, namely 2 upraised hands, and they can add hands to the hieratic sign in order to complexify it in a way that is sort of intuitive. And what I think is really interesting about this is if you compare the hieroglyphic examples, they don't borrow the form from the hieroglyphs. They kind of invent their own way of representing hands, especially in the Middle Kingdom. They just add these little cups. And we can see the same thing in the G35 sign. In the Old Kingdom, it's a very simple schematic bird shape. In the Middle Kingdom, you get this shape that we're probably all familiar with from studying hieratic. And then in the Greco-Roman period, you get these fabulous boys. They have big tails, they have elaborate crests on their head. And what's interesting is this appears nowhere that I could find in any hieroglyphic example. So polychrome hieroglyphs, epigraphic hieroglyphs, even cursive hieroglyphs, you never see these features. So then my question was, like, where are these things coming from? And I had an idea, and this leads me to a really interesting hypothesis. It's quite speculative, but I think it's rather fun. If you look at the actual bird that this sign represents, namely a cormorant, it does sometimes have a crest on its head. So when they wanted to complexify the sign, they're adding these iconic elements, but they're not doing it in reference to the hieroglyphic form. They're doing it in reference to the actual real-world referent of the sign. Then the question is, like, how did they know? How did they know to add a crest, or why did it occur to them to add a crest to the sign? And my hypothesis is that these signs had names. All written languages have names for the signs in their script, including English. We don't know what they were in ancient Egyptian, but it's quite reasonable to hypothesize that they were simply the name of the entity that the sign represented. And if that seems far-fetched, I'll just quickly remind you that in the Paleo-Hebrew script, the signs also have names, and they are the names of the entities that those signs represent, and they retained those names long after the signs had been so abstracted that they no longer resembled those real-world entities. So Aleph is the head of an ox, Beit is a house. They don't look like that anymore, but they still retain those names, even today in modern Arabic. So I find this really fun, kind of a secondary consequence of doing this research is this, I think, really interesting hypothesis. How did they name the signs? How did they discuss the signs? And did ancient Egyptian scribes writing in hieratic, who didn't necessarily work with hieroglyphic, know what those signs represented in the real world at all times? And then just returning to this, what we're trying to find here is the underlying mechanisms by which script evolution works. And what we're really seeing here is that the way that the sign forms vary is not simply an increase in abstraction or a decrease in iconicity. In fact, they can change in both directions at once. But then their change is not random. It's directly connected to the way the script encodes information. So we have this much deeper, more informative connection that helps to explain or helps to better understand how the script evolved over time. So thank you very much for your attention.